You see all those signs in Japan, Japan, that are always so cool and sparkly and remind you of arcades? You
Yeah,
want to know how
the
those are made?
LEDs, light emitting diodes.
I don't think LEDs use neon.
No,
I'm
I
pretty
think I
sure
think they transitioned away from neon because it's very expensive. Anyways, today's episode is about
neon.
neon.
Yep. So, welcome to the second noble gas episode. Last one was helium, but that one, it's weird valence electron shells. But we're in like the octet rule land now, so
Yeah, we're in
it counts.
standard periodic land. Also,
True.
if you comment anything about that anime, Neon Genesis Evangelion Neon, no, there's an anime with it in the
I
title.
don't know
This
what
is
you're
not
talking about.
that.
Some cool facts about neon is it's atomic number 10. Whoa, it's a noble gas. Whoa, that means it does not like to bond to stuff because it has a full octet. And so you usually never deal with it in chemistry, except in effectively lights. It used to be a common used substance to create neon lights. So kind of cool.
So the reason it works like that is because when you put a bunch of energy into a gas, it does what's known as...
The electrons are going to jump up and down transmission levels, which
Yeah,
will send off specific photons.
It excites the neon. And so all of the electrons in your neon, they have these bands of light that they really like to emit at, and it looks very bright and very cool. So I'll put up right now the emission spectrum, and that is actually looking at excited neon gas, at how it comes out, but it looks already like neon lights. And so when you have lights in your room, you're just putting a bunch of electricity through gases. Probably some of it is a neon.
No, most of it isn't, because neon's fairly expensive. So they only do it for specific lights. Usually a little bit of light bulb fun facts here. The original light bulbs, incandescent light bulbs, they worked by having a inert gas. Sometimes it was neon, but it was just whatever they could get that was inert in a light bulb, like a casing. And then through it, you ran a filament, and that filament would, it was a resistor effectively, like a really strong resistor. So it would get really, really hot. And once it reached a certain heat, it would start to glow white hot from the black body radiation from it. So that's the long and short of how most light bulbs work. I don't think they use neon though, because neon lights is done by running a field or a charge through the gas itself, right? Like you're literally exciting the gas in the tube to make it glow. Yeah. So, I'm not sure how they get different colors.
That's used most of it in the 80s. Well, there's like two main ways to change the colors. One is to color the glass, and then the other is to include different mixtures of gases until the color reaches approximately what you want. But yeah, it's not like the frequency, but it's if you put a certain amount of energy in, it'll kind of isolate the emission level, or it'll combine the emission level and like additive color theory.
Interesting. What's interesting here is that they add mercury to make it brighter. I wonder why that is. That's maybe because it conducts electricity better, but then that makes the neon lights fairly dangerous, because if one of those explodes and you just get a bunch of mercury all over you, so that would be not good.
So anybody who's wondering, the name neon comes from the Greek word for new, but it's because they wanted to use the Latin word novum, which means new, but apparently they chose to go with Greek. Yay.
Huh. Apparently there was a major shortage in 2022 because of the Russian annexation of
what did they do?
Crimea.
Why did they need
apparently
neon?
In 2014, neon prices jumped up 600%, which then pushed it to China. And then when Russia invaded Ukraine, that shut down the two companies in Ukraine that produced half of the world's supply of neon.
Nice.
And apparently in Odessa and Mariupol, I think that's how you say that. So apparently neon is necessary, probably because it's an inert gas, to produce chips. Because oftentimes a lot of those chips require extremely fine environments to produce them correctly. So that's pretty crazy.
Neon can technically bond. This is similar to the whole how fluorine can make 8 bonds with xenon or whatever. So neon will bond with chromium. Chromium is a really silly guy. He bonds to whomever. He does not care. Neon will form a weak bond with chromium in certain complex structures. And you can also have ions of neon argonate with argon, neon hydride, I suppose, and helium-nelium.
What?
Helium with neon.
Okay, look this up. Clathrate hydrate of neon. Apparently, under specific conditions, I assume it's not water, but it's like something. Oh no, it is water. Water can form these cells, which will capture inert gases to create a like an ice-looking thing. This is super weird. So apparently, like water-based solids, which resemble ice, capture non-polar molecules such as noble gases inside these little packets in the crystal structure, and it is so weird looking. Like clathrate is found naturally in large quantities at the ocean floor. They believe 6.4 trillion tons of methane is deposited as methane clathrate on the ocean floor. That's crazy. A lot of it near Norway. That's probably some, like, if you could figure out how to purify that, you could turn that into some fuel, probably. Not powerful fuel, but fuel.
So the process of getting your hands on neon involves, you need to have the atmosphere first, which has some neon in it, like 18 parts per million. So in a million bits of atmosphere, you'd only have 18 neons in there. So neon has a boiling point of negative 246 degrees Celsius. That's negative 400 in Fahrenheit. And helium and hydrogen.
Really cold.
Helium, hydrogen, and neon will stay in the gas form when you get it that cold. Everything else will fall out of the atmosphere that cold. And so you need to then have activated charcoal brought into contact with this very cold, I guess it used to be air, now it's this mixture of hydrogen, helium, and neon. If you bring activated charcoal, it will absorb the neon and the hydrogen. And then you have to remove the hydrogen by adding enough oxygen, which will then make water and leave you with neon. And
it looks like it doesn't absorb the neon. It just looks like it maybe absorbs the hydrogen and whatever other impurities are left. Then once they get that out, they use low temperature adsorption, which is effectively where you have a column that bonds to a specific particle on the surface to remove the remaining helium. So you remove the hydrogen with the activated charcoal, the helium you remove with an absorption bed or something, and then you got neon.
And yeah, this is a super duper not fun process. Apparently, 88,000 pounds of air, liquid air, will make 1 pound of neon. That is terrible. That is horrible. That's like worse.
Terrible.
So you know how people complain about like making maple syrup, how much sap they have to boil? This is like that, but way worse.
True. Neon was discovered when Ramsay chilled a sample of air until it became a liquid, then warmed the liquid and captured the gases as they boiled off. The gases nitrogen, oxygen, and argon had been identified, but the remaining gases were isolated and roughly their order of abundance. In a 6-week period, begining in May 1888.
Yeah, they knew that it was
the first gas identified was krypton.
They knew it was neon because it had a unique glow, like it had a unique emission spectrum.
Yeah. So apparently they also discovered krypton in the same experiment. That'd be pretty cool. You could name 2 different elements.
Well, they picked pretty shitty ones because krypton is where Batman's from.
True, good point.
And neon is 1 letter away from being the protagonist of the Matrix.
You're right. Or Nemo. Choose your favorite.
I think that's going to be it from us, yeah. Thank you, everybody, so much for watching, and we did it. We've done 10 episodes of periodic elements. So we should probably explain...
If you're liking it, let me know.
We should probably explain a few more elemental rules in one of the future episodes. Probably electronegativity. That's probably going to be coming up soon.
Yeah. I know so much Okim. I don't want to know Okim, but I must.
Well, thank you, everybody, so much for watching.
Ciao.